So that's the cool thing here, what's great about this section. You can have non-functions. Like that. You can still get the slope right there. You can still get the slope right here by this technique. Implicit differentiation is going to be very helpful when you have non-functions. Things like circles. Because you will still get slope, but we just got to know the technique. Okay? Now some of you go, hey, we can solve for y here, subtract x squared, but don't you get a plus or minus? I know, doesn't that get weird? And what if this thing had like x cubed y, and then xy squared plus, you know, all this other garbage. True? So, implicit differentiation. Step 1. Differentiate both sides of the equation with respect to x. All right, that's going to be our first step. Let's differentiate both sides of the equation with respect to x. If you want to put that down as a step, you can. I want to give you time to write that. Implicit differentiation. Differentiate both sides of the equation with respect to the letter x. Because there's x's and y's here. Okay? Differentiate both. I'll write it in math notation. Differentiate both sides of the equation with respect to x. By the way, I think you're going to find this right side real easy. What's the derivative of any constant?
0.
I know, but students sometimes always write 9 here. So be careful. The derivative of 9 with respect to x is just a what?
0.
Oh, that right side was easy. So I have to differentiate this x squared plus this what?
Y squared.
All right, so now look what I have. This may look weird. And when I need the derivative
So 2x.
with respect to an x of x squared, that's going to be a piece of cake. I'll put in yellow the part you and I are going to be careful on. And then you and I will come up with a system that make all implicit differentiate problems easy. Piece of cake, that's the one we got to be careful with. So step 1, differentiate both sides of the equation with respect to x. Okay. You know what the derivative of x squared would be then? 2 what? 2x by power rule is a piece of cake. Here's the tough one. Differentiate this right there with respect to x. Hello, that doesn't have an x in it, does it?
No.
Do you see what I'm saying? Do you see, I should say, do you hear what I'm saying, right? It's kind of weird, isn't it? Differentiate this with respect to what letter? X. You go, what are we going to do? I mean, we're just going to apply chain rule. And don't let it freak you out, because it's the first time you're going to see it. You go, what? We're going to apply chain rule. All right, we're going to do this. You're really?
Mm-hmm.
Yeah, just do your typical derivative. I'd have to take the 2, right? Multiply it in front. That's not an x, don't worry. Decrease this by 1, what would that power be? 2y to the what? First power? Now, you just did all this. But now I have to multiply the derivative of this letter y with respect to x. That's called chain rule. This was the chain of this. I don't want to make this more confusing than it is. You go, what happened? I'm differentiating a y squared with respect to x. So all I did was think of this like almost like a u squared. Seriously. It was like a u squared. I'd be like, oh, it'd be 2 in front, u to the first power, times the derivative of that letter with respect to x. Okay, so I don't want you to get so hooked on this like it's so weird. Even if it was this, let's say it was a u squared. You know what I'd done? To differentiate that with respect to x, I would have said 2 in front, decrease this by 1 power, then multiply the derivative of this with respect to x. Just like that. That's the chain part. That's the chain part. Just like this is derivative of g with respect to x. Maybe it helps here. You just go, this really, and another way to write this is this. dg with respect to x. That's all we're doing. That's all we're doing. So what I'm doing here, I want to use, so what if it was like a g squared? Find your derivative back to x. Oh, chain rule, 2 in front, decrease it by 1 power, then multiply what? The derivative of this letter with respect to what? X. So, that's the theory behind it. We're using chain rule here, but I want you to keep it simple. How about this? Every time we're doing this implicit differentiation, and we differentiate a y variable, guess what? We can always write right next to it. Just a what? dy dx. Cool? I'm serious. Let's do that every time. I mean, we'll do the derivative of x squared, because that would be like a dx over dx. But every time I differentiate a y variable, right next to it, I'll just write what? dy dx. This is really this part right here, which is like that. But keep it simple. Don't think it's like, oh, this is a crazy section. Just every time I'm taking a derivative, and it's got a y in it, I'll do the power rule like this. I'll do the power rule, but right afterward, what will I write? dy dx. Okay? Hey, who's had calc before? Some of these students in there, they're saying to themselves, well, they're not going to write that. They've got an easier notation. They just write this. Isn't that dy dx? You can, but I'd be careful with that. I won't as an instructor, because sometimes my y primes, right? Y the first power, it gets sloppy. It may look like y, it may look like something different, like a y the first power. Right? You may think that's y the first power. That's a y prime. Cool. Hey everyone, great job with this so far. So, differentiate with respect to x. We did it. I had to apply chain rule here. That was the hard part. Last step, I need you to solve for dy dx. I need you to manipulate, this is the last step. You need to manipulate this equation and isolate the dy dx. Our goal is to find the derivative of y with respect to x. I should put that over here. What was the directions of this problem? We're finding dy dx. We're finding the slope to the curve. Cool? Hey, any suggestions how I can isolate that?
Yep.
What could you subtract on both sides?
2x.
All right, let's subtract this on both sides. All right. And when I now have 2y dy dx equals negative 2x. Now, how can I get this 2y off that left side?
Divide by 2.
Divide it. And I think I'm done, unless you see something I can simplify. Anything cancel?
2.
There it is. This will find the slope of any tangent line to the circle. And when this will find the slope of any tangent line to the circle. So I say we have some fun here. I'm going to draw the circle. Anybody know the radius of that circle?
3.
Is it 9 or 3?
3.
So here we go. Pictures help us see things in math. Let's draw a picture. Radius 3. Let's find a few slopes, okay? All right, when that point right there is x equal to 2 and y equal to the square root of 5. That's the point on that circle. Do you agree? What's 2 squared?
4.
4. What's the square root of 5 squared? 5. 4 plus 5 is what? 9. So that's why I was picking a random point on this circle. Can you find the slope there? There's your formula. And we'll all just draw a tangent line and pick what's the slope going to be? For this formula, what would it be? Just put in m equals
2 over negative 2 over root 5.
negative 2 over the square root of 5. All right, let's just pick another point on this side. How about this point right here? How about the point negative 2 for x, y is square root of 5? Would you find the slope of that tangent line to the circle?
So that should
Plug it in there. That gives you the slope, right? Slope of tangent line to circle. Slope of tangent line to curve. How cool is implicit differentiation? You can find slopes of curves that go like figure eights and stuff, you know? You get slope here, get slope here, get slope here, you know, you can do it with this stuff. Cool? Hey, what is that slope? And when I get negative 2 over
5.
square root of 5, which makes it what?
Positive.
Hey, does this flow with our picture? Positive slope, negative slope? Oh, one of my favorite parts. I don't even know if you're gonna need this formula. Anybody know the slope right there?
0.
You are good. I heard you were quick. Why are you like 0? We'll plug it in, you're still gonna get what? 0, right? What's another goofy point? How about right here? I think you all will know. Right there, what's the slope of a line like that? Undefined, and that point everyone was 3 comma 0, so if I plug in negative 3 over 0, you bet that's undefined. Look, it's an undefined slope. See how this gives you the slope at any point on this road. But keep it simple. Put it somewhere in your notes. Say implicit differentiation is actually easy. What I have to do is I differentiate everything, right? Respect x. But now if I ever get a y and I'm differentiating with respect to y, what do I write just right next to it? You know, y squared. I wrote 2y by power rule, and right next to it I wrote what? dy dx. Now if you're wondering why, the theory behind that is just chain rule. That's what it is. It's just, it wasn't an x, it had a y, so I did L. Different letter, 2 in front, y the first, and then the derivative of that letter with respect to x. Great job. Hey, can we try another one? Now, I like to build slowly with implicit, okay? Build slowly. Here's my next one. And by the way, if anybody ever wants me to go up till second derivative here, I would. I think the textbook does it. I know. Seriously, you're like, hey, how about go get the second derivative? You go, okay, but do you know what rule you'd have to apply?
You can do
You
product
see it?
or
I got a
quotient.
fraction, what could be good? Quotient rule, good job.
Quotient or product, anything.
Right?
You can do product too.
Oh, and he goes, you can put that y in -1, do product also. That's the good thing about it.
So this
Very
is-
good.
This is like an oscillating function.
That's right. That's exactly right. All right, well, here's my next one. I just thought I wouldn't go too far away from the last one. Well, how about that? Let's just go slowly and then we'll take it up a notch. Everyone, I want you to find dy dx. Then we'll go to something tough, huh?
This is in section 3.5.
Give it a shot. Remember, just differentiate everything with respect to x. But when you're differentiating that y, just write dy dx next to it. Okay? Hey, here, differentiate that with respect to x. What would you get?
0.
What's your in that respect to x?
3x squared.
Okay. Implicit. It's easy. Huh? Y'all agree? This is it. Oh yeah, but what do you do here?
Plus 3y squared.
And the bells are going off. I am now differentiating something with what letter?
dy dx.
And according to our rule, what do I write right next to it? Do y'all see that? Because I differentiated something with the letter y. I applied chain rule. That's really what I'm doing. That's why chain rule always precedes this section in every calculus textbook. That's all I'm doing. But you can keep it simple, right? Keep it simple. Oh, I just differentiated a y. I'll write dy dx, right? And I don't want you to just do it without any meaning to it. You can always say it's coming back. This is what we're doing. You're just writing something like that. That's all you're doing. Except instead of a g, it's a y. That's the only difference. Hey, what do you get for your answer then? Subtract the what?
3.
This answer's like the last one, huh? Can you say bye?
When you increase the power in the equation, does the derivative automatically increase by 1 as well?
Which part? The
Because the last one was negative x over y, and it was only x squared plus y squared. This
Oh,
is x cubed plus y cubed.
Oh, that's right, that's the only difference.
No, I'm saying, does it do that all the time?
That's right.
Yeah.
That's exactly it. And the reason I stepped it up like this, Kel, ready? This 3y, sometimes people think that the derivative of y cubed is just 3y, right? If they say differentiate, you get just 3y. The derivative of y cubed by power rule is 3 in front and y to the what? Second. But you're right, what if this was y to the sixth? It'd be 6y to the 6y to the fifth, and then right next to it I would write dy dx. Cool? So, how hard do these get? Something like this. And you got x to the fourth. Oh, that was easy. Oh boy. Oh boy. Oh. And you might think, oh, I should factor for, nope, that one. Step one, we differentiate everything with respect to what letter? X. X. So that 11 is going to be easy. I'll just turn to what? 0. That x to the fourth will be easy. What will it turn into?
4x cubed.
So here we go, look. Differentiate. We're looking for dy dx in this problem. We're looking for the slope of this goofy curve. I have no idea what it looks like. But that's 4x cubed. Remember, get it? Yeah, cool. Hey, go way over here. What's this? Because that's easy. Easy part first. 0. I think you're used to this now. What will that turn into? Because it's got the y.
2y dy dx.
Differentiate, all right, it's got the y. 2y to the first times
dy dx.
dy dx. Everyone, if you read through your textbook, your author writes it like this. Because isn't y prime dy dx?
Mm-hmm.
True? But I will not write it like that on the board. I'm worried you think that's y to what power?
1.
Y to a first. I just got had y to a second. You might think that's y to